We're elated to now move on to our next session on the topic, how CDNs, which is content delivery networks, are helping gaming companies improve speed and performance. Well, for this, we're going to be joined now by our speaker, Charles Cos, the Senior Product Marketing Manager, Limelight Networks. Well, Charles is a product marketing and a product management executive with extensive experience in high-tech, global, entrepreneurial, and corporate environments. Well, business strategy focused with proven accomplishments driving multiple rapid growth programs. Currently at Limelight Networks, he's focused on media and broadcast solutions with product responsibilities in video and security. Well, with this, I'd now like to invite on the stage and screen, Charles. Thank you, Charles, for joining us. With this, the stage and screen is all yours.
Good day, everyone. This is Charlie Kraus from Limelight Networks. So the tech talk for today will be about how content delivery networks can help improve the performance and speed and just the general gamer experience for playing online games. So just a little bit about my background. I've been at Limelight for 7 years, and I look after all of our online video solutions. So that includes live on-demand video platform, as well as security solutions. So like DDoS protection, web application firewall, bot manager, et cetera. And just over my career so far, so I've got about 25 years of experience between large global data networking and video distribution. So there's a couple of challenges that gaming and esports have, and I place these together. So because of the experience watching major esports events, most gamers really want to have a similar kind of experience in terms of the way the video looks, the game performance, et cetera. And they watch how professional teams play, and they really like that experience, and they try to learn from them. So anything you can do to increase the speed of play and the whole experience is important. So one area we'll talk about especially is downloads. These games are very large. We have seen games exceeding 100 gigabytes in size, and there's even a few that are even at 200 gigabytes. So imagine having a new release of one of these games, and then having sometimes even 1 million gamer enthusiasts trying to download those, and you can do the math. That's a huge amount of download. How do you do that? And as well as downloading the games, when they want to watch these big events, and I put in a little picture here of typically what you see in these. Usually they use a big sports stadium, and a stage is in the middle, and they have the teams that are up there playing. And the viewers want to watch these games. They often like to make comments during the games. And so you need to have a low latency streaming out to the audience that's watching, so that as they interact with each other and make comments, it's fairly quick, and they're sort of in sync with the actual stream. And we'll talk about the technologies that allow that. And then of course, protecting games. Just like any other video, there's always people and problems with bot attacks or DDoS attacks or security of the games and so forth. So there's a whole suite of different technologies that are important to use for protecting the games, and we'll cover those as well. So I hope this is going to be very useful to everyone. I'll try to fill in as much information as I know as we go along here. So the best way to explain a lot of these things is a case study I have. This is a company called iRacing. So this company started just during the pandemic, and what they have created is quite an amazing simulation of all sorts of motorsports racing that you can do online. And it was originally intended for just people that are at home that want to be in simulated motorsports racing. But when fans could not be at motorsports events, or they didn't allow events at all, that in many parts of the world, they use this this game to actually have the motorsports racing online. And I'll show some images of that. So they actually had the actual professional race drivers in a studio in their homes that was set up like they're in a race car. And this is really showing the benefits of download performance. So what iRacing is, it's regular motorsports, and the video simulation is quite an amazing thing. They have modeled perfectly the performance aspects of about 100 different car replicas. So everything from rallies to Formula One to the kind of racing you kind of see in the picture here, but the cars perform like the real thing. And they've also have measured accurately about 100 of the racing circuits around the world, so that the tracks that they race on that are popular, it's exactly those tracks. And so the simulation of the tracks is also perfect. So this allows things like team racing. So people and their friends can create a team and make their own racing leagues, which is very popular in some parts of the world. So that teams race against each other on these tracks, or people can just go in individually and just race against other people that are on the platform. So, and as I mentioned, during the 220 timeframe, these were actual professional races were held using this platform. So the challenges they had is these files are not as big as some of the games like team games, but it's but 5 gigabits, but there's a huge number of people that are doing this. And so at the beginning of every racing season, they have to have a new version of the game, which is 30 gigabytes. And so all their members can download that just before the first races. They found that in different parts of the world, the performance wasn't always the same. This could be because the local connectivity in a particular region may not be as good as others, so it would take longer to download, or the internet connection maybe was poor quality. And the iRacing engineers were spending a lot of their time helping their customers get the downloads going. And that was taking time away from actually continuing to improve the game, adding new racetracks to it, and so forth. So that was a big problem. So that was solved, and we'll talk about how they did that. So I show these images here because this is very typical. I took these from events that were done in 2020, and the driver that we see here is an actual, in this case, it's NASCAR, which is in the United States, down in the South, a popular form of motorsports. So they actually have this very fancy cockpit that they have in their house, and these large screens to play the game on. So they have steering wheel, gear shift, all the pedals. So it's just like the cockpit of a race car, and it's set up like this, and that's what they race in. So the CDN that they use, so they use multiple CDNs, and what's really important is that the peering relationships with all the major global ISPs are the best ones. So people that participate could be anywhere in the world, and they want to make sure that their local experience and their local speed is the highest performance it can be. So it's important to have CDNs that have this really powerful, good internet connectivity. And then the CDNs they use, they have to have the capacity to support all these downloads for the games in every region, which is why they use multiple CDNs. So in any one region, no CDN is maybe the best, but between using 3 or 4 different CDNs, they can get the best performance possible. And so this starts, they all get the new racing things, and then they can start the beginning of their season. So the solution to this is for downloading game files is using the CDN capacity that's generally called content delivery. So this is not transcoding video or anything like that. It's just really making sure these large files can get delivered and sent down. So it's a couple of things are important. It's certainly link speed is important, but you need to have storage, because to get these large files distributed all over the globe, you have to have copies of this in POPs all around the world stored and replicated so that there's redundancy. So features like automatic replication is important. For the CDNs to map the internet connectivity so they pick the best paths to send the downloads to. Private networks help. Limelight Networks happens to be a private fiber backbone network, so that helps performance. And so automating a lot of this takes the work out of managing these downloads. So automated replication, so every file is stored in multiple places strategically, depending on where users are. When the downloads are coming to the individual users, software detects the optimal point of presence to use, because in any region, CDNs will have multiple POPs, and you want to pick the one that's the best for a particular use case. And by having a private network, this bypasses the internet, because the internet's congested with movies and TV shows and all sorts of entertainment as well. And so avoiding getting congestion on that is very important for this. So the result that they found was, this is in the beginning of their new season. They implemented Limelight CDN as one of the CDNs for this, and they did it with the help of advanced architects. So one of the things that's important with CDNs is to have good professional help in implementing them and in configuring them, because you want to optimize the configuration for the best possible performance all the time, and having solution architects with vast experience in doing this is important when you're setting these up. So everything was running just in time at the start of the new season, and they noticed right away that they were getting favorable comments from their gamer customers that compared to other years, that the download performance was fantastic. It happened perfectly. They didn't need to call tech support in to help, and they were able to very quickly now start the new racing season. So this also meant that the iRacing team and the engineers didn't have to spend their time troubleshooting connectivity issues like this. They were spending their time creating new racing circuits, creating new car simulations and so forth, and making the game better. So that's really what they do best, is that kind of development, and that allowed them to do that. So now let's look at from the point of view of viewers that are watching the races online. So there's a couple of different things that are possible now because of low latency. So one is that, and because of IP delivery, is that you can deliver multiple streams to users. So in the picture here in the upper left, I'm showing a view from inside a race car. So what they make available is you can have different views of the track. So most of the time they may want to watch from inside the motorsports car of maybe a racer that they find very popular. Or they may just want an overall view, like you might see on a broadcast. So it's just having cameras following all the cars around the track. But giving them that choice of which kind of camera to watch, which car, maybe watching multiple cars at the same time so they can watch them pass each other and so forth, has become very, very important. So the idea of scaling these live streams to have multiple streams to each viewer, and with the large number of viewers, you need a lot of capacity to do that. So we're about to talk about a new streaming technology that's starting to become popular now. It's referred to as low latency streaming, but the real idea here is to match broadcasts. So typical television coverage with broadcast is about 5 to 6 seconds latency from the live event to a viewer's screen. So for this use case, you don't need what's called ultra low latency, like real-time streaming, where it's less than 1 second, because as long as you're watching, having the same kind of latency as like online as you do for the broadcast, then people watching and racing against each other all see the same thing at the same time. So matching the broadcast with 5-second latency is really the goal here. So this is really to improve what we call second screen or multi-screen viewing, so that people watching a broadcast in any kind of a sporting event or people watching online see everything at the same time. So this eliminates a very common complaint from viewers that they were before, when the online streams may have been 30 seconds or 1 minute longer than a broadcast, they get complaints about somebody doing a social media text about a play or something that happened during the game, and they haven't seen that yet. So using this 5-second low latency streaming technology, everybody sees everything at the same time. Very important. The way this is done is it uses HLS and Dash. And the choice here is because almost all events today, live and on demand, are delivered through HLS and Dash to all devices. This is just a new technology for delivering Dash and HLS. And it uses something, it starts with something called CMAF, which is Common Media Application Format. Now, it's kind of a deep topic to go into in this webinar, but you can find online lots of information. But the general idea is it's using something called chunk transfer encoding. So all online video is done by sending chunks of video, but typically online video has used 10-second chunks, and you made a buffer of maybe 3 to 4 chunks. And that's where that 30-second to 1 minute latency was coming from. But with chunk transfer encoding, you build micro chunks. These chunks can be in the range of maybe 100 milliseconds, 200 milliseconds, something very small. And that helps latency a lot because your little buffer now is just smaller chunks. But the really important part is that the player can start delivering chunks to the viewer before an entire segment is encoded. So as soon as encoding starts, the first chunks that arrive are started to play immediately. So this is how it's able to provide 5-second or so latency for HLS and Dash. So a couple of things you're doing here. The global CDN infrastructure from all the top vendors is typically delivering terabytes of capacity for HLS and Dash. And most viewer devices receive HLS and Dash. So it's leveraging all the infrastructure that's in place today and just having better technology for sending video across. There's full support of adaptive bitrate, all the kind of security things like DRM and so forth are supported by this. And again, it matches the broadcast latency to the stream. It also allows you to add some enhancements so that 5 seconds latency and so forth has the ability to do insertion of maybe targeted ads into a stream and so forth. So this is just a generic workflow that I'm showing here, where the video source is encoding to CMAF format, and what's being delivered to the CDN edge is either low latency, usually both low latency HLS and Dash together. And there's 2 choices that you have here. One is typical pull, where users that want to get a video stream request it, and it is pulled from the origin. But one of the things about these large events is that there's a large number of people that can go into the hundreds of thousands or millions of pulling all these streams. And that puts a huge burden on the content owner's origin. So they're getting all these requests for all these streams. And that causes them to have 2 things. One, a very expensive origin infrastructure to support that. And the link that they use to send traffic to the CDN has to be a very high-speed, high-capacity link to also support all those streams. So a more efficient way to do this is something called push, where the video source only has to send a single copy of a stream and pushes that to the CDN, where there's an ingest server that takes that. And the CDN does all the work of receiving the requests from the hundreds of thousands or millions of users, and they replicate the streams and send them out. So the CDN is built for this. It's built with the solid infrastructure, the high capacity servers, and points of presence to be able to distribute that out. So you have 2 choices on how to do this. So generally for the larger events, push is expected to become a very popular way of doing this. So this is what the live push looks like. So the CDN has a different type of ingest. It's a push ingest server that takes in that single stream. It does it redundantly, so you want to have a redundancy, so you want to ingest in the 2 sets of pops. It also has auto failover, so if one of your ingests fails, you have a backup. So this reduced the egress cost because now the links don't have to be high-speed links. You're only delivering 1 stream. It protects against ingest failure. It eliminates the threat of overloading the content origin that the content owner has, so he won't get overloaded. And it simplifies multi-CDN delivery because, again, 1 stream can be used to deliver to multi-CDNs. Video security. So last but not least, so there's a suite of security services that are very important when you're delivering video. Things like digital rights management's DRM, which encrypts the streams. So you have to have a license so authorized subscribers can decrypt it. You want anti-piracy. So one way of deterring piracy is something called watermarking, where you can determine where the source of the original file was that people are copying. And of course, like global encryption, SSL, so all streams are encrypted in transit going to users. URL tokenization is another way to protect it by having aspects like videos are only available during a certain time period or a certain day or for a length of time. So it lessens the exposure of videos to piracy by minimizing the time that they're available. Geolocation, very important, because a lot of licensing has depends on restrictions to certain geographic regions. So people try to use VPNs to disguise the region they're from to get streams. So having a geolocation software in the CDN can detect when a VPN's in use and then refuse the stream. And then just general access control. So this is a way to use things like whitelist and blacklist of authorized users, again, geography, time of day, and so forth, and different ways of controlling access to. So that is the final slide here. So I hope this is useful to people. We would be very happy to engage with anyone if they're trying to improve their e-gaming and esports distribution and streaming and downloading and so forth. So if there's any interest in that, we'd be happy to talk. So again, I hope this was useful, and we look forward to having you again in a future webinar. Thank you.
Well, thank you so much, Charles, for that great session.